It says live.
We are live. And thanks to everybody who is joining us both here in Research Triangle Park, North Carolina at the Bitcoin and Business Meetup, and everyone who's online watching the streaming. We have Zooko, who is an old school cypherpunk, continuing with the cypherpunk traditions, keeping the spirit alive. He's got quite the impressive resume behind him. But tonight we're going to learn all about Zcash, which is a brand new blockchain that's using some fancy cryptography to really give us a strong privacy guarantee when we're transacting online. So Zooko, I'll go ahead and hand it on over to you. Thanks.
All right, thanks. I'm presenting to everyone. Okay. Oh shoot! Now that I'm presenting to everyone, I can't screencast. Oh, I can screencast. Yeah, here we go. So that everyone else can see what I see. Everyone on the live cast. Here's the Triangle Bitcoin Meetup. So I brought some slides, but I'm definitely counting on people to interrupt. These are kind of like choose your own adventure slides more than slides that I intend to go through all of them. So Jameson, shall I call you Jameson? Is that how you're referred to?
Yeah, just like the whiskey.
J-Lop. Can I count on you to like interrupt me and let me know if people have any questions? Because these are like choose your own adventure slides, and I'm going to pause after a few minutes and say, which way do you want to go from here?
Yeah, sure, no problem.
Okay. All right. Thank you. Thank you all for listening. I'm Zooko. Here's my brief description of Zcash. I'm going to leave lots of time for questions. There are 4 things, but aside from the first one, I'm basically going to wait until somebody asks about one of the other 3, and then I'm going to go down that path. Hold on, I'm getting feedback of my voice, which is going to make it hard for me to keep talking. Take off my headset or something.
I can also mute the mic over here.
Okay, if you mute that mic, then let's see if I'm not hearing my own voice so I can keep talking. Okay. Okay, first of all, basic idea. Zcash is like this. We decided to go create a blockchain and cryptocurrency with really strong privacy. And I'll pause right there. Why would we do something like that? Well, stop screen sharing. There. So we set out saying Bitcoin is super awesome, and it's a delight and a revelation that such a thing is possible, and we love it. And it opens up so many other further possibilities. If Bitcoin is possible, then what else is also possible? But Bitcoin's traceability is a major problem, and not one easily fixed, because we had a background in privacy technology, and we know that if you have a whole bunch of data, a whole bunch of information being leaked like that, then it is not at all easy to regain privacy by sort of clamping down on the leaks a little bit, reducing the leaks, because the degree to which even a small amount of information leakage can be leveraged to violate privacy and to degrade fungibility is often surprising to people. Okay, real quick, how many people already know what fungibility means? Raise your hands. Everybody knows what fungibility means except for that one guy over there. So for his sake, my definition of fungibility is that if you're going to pay someone with something and you have 2 of them, it doesn't matter which one you give them. And that is, of course, necessary to use a thing as money frictionlessly. If your money doesn't have fungibility, it becomes awfully complicated to use it for transactions. So we set out to develop a blockchain slash cryptocurrency with really strong privacy for fungibility for all kinds of mainstream business use, which requires fungibility, and also for privacy because we believe that privacy is a social value that strengthens and protects and enriches societies and enables the exercise of human rights like political participation and moral choices and everything else. So we're very passionate and committed to this project. So what we did was screencasting. We took Bitcoin and git cloned it, Bitcoin core code base. Wait a minute, there we go. And then we added shielded transactions, which are the reason for the existence of Zcash. And I can go into more detail if you select the under the hood choice from the choose your own adventure. And then we added a bunch of other things. The first three all kind of come together, and the latter two on this list are orthogonal, and we could have kept them or take them or leave them. But the first three are shielded transactions, which means encrypted transactions on the blockchain. And the next one's selective disclosure, which is like this. Cryptography is using cryptography to enforce confidentiality or privacy. That means that there's some information, which is the key, which is necessary and sufficient to decrypt and gain access to the data, right? Well, that implies that in addition to being able to decrypt the data, you also have the power to disclose the key to someone else, and that would enable them to decrypt the data. That's kind of a less well appreciated fact about cryptography, but it's just a consequence of using math for enforcing confidentiality, that you get selective disclosure, whether you like it or not. So we've made a virtue of it in Zcash and made selective disclosure one of the features that you can take advantage of when building on the blockchain. And hold on, let me figure out how to stop sharing. There we go. This part's really neat. I don't know how, I don't know what you can build with this, but the basic qualities of a blockchain are append only and canonicity, right? Everybody nod your head so I can see the backs of your heads move. Append only, canonicity, okay, on the same page. Append only means you can't go back and change your story later, and canonicity means you can't tell two different stories to two different people. Well, encryption provides its own properties, privacy, and selective disclosure. And with Zcash, you get the combination of all the properties. You can add things to the blockchain in an append-only canonical spot. And by doing so, you can do so while keeping the data private. And you can later selectively disclose the data to a specific party without disclosing it to arbitrary other parties. So that was, switching back to sharing, that was, so the top three things put together give you the ability to use this combination of properties of append-only, canonical, confidential, and selectively disclosable. So the third thing there is encrypted memo field. We made these encrypted transactions. I should stop and tell you a little bit more about the whole concept of encrypted transactions. So look at this. Here is oversimplified Bitcoin. So Bitcoin is a spreadsheet with 4 columns, and each row looks like this. And it's awesome that you can do this without a centralized spreadsheet, but Bitcoin is a decentralized spreadsheet, so that's awesome and a breakthrough and fascinating. And you can immediately see the data confidentiality privacy problems arising because everyone who's looking at the decentralized spreadsheet can link that transaction to that transaction And they can tell that address B received 3 Bitcoin here and sent 2 Bitcoin there and so forth. So you immediately start losing. Well, here is oversimplified Zcash. It's got the same 4 columns, and then it has a 5th column, which is the zero knowledge proof, which we're using as a black box for now. And these 3 columns are encrypted on the blockchain. It's pretty mind-boggling that this even works. But so this is how this is actually possible because the zero knowledge proof in the 5th column was produced by a prover who knew, namely the spender, actually, who knew his own address and the recipient address and the amount spent and so forth. And so he produced a zero knowledge proof that all of the miners and all of the full nodes, anyone looking at this decentralized spreadsheet, can verify that this transaction is correct without knowing anything about, without disclosing any of the confidential information about the sender, recipient, or amount. Okay, and then if you're the recipient, you can see this. If you, okay, this is actually an inaccurate slide, but all right, look, here, I'll fix it. You're not going to see that part. That's the issue. That's why this is inaccurate. If you're the recipient, if you are person or user C, and you see that you got a payment, by design, it doesn't disclose to you any identifying information about the sender. It only discloses how much and when you got it. So we started thinking, where are my slides? So we started thinking, to make this usable to accept payments for goods and services over the internet, you need kind of like a memo field on a check where you can write in, like, this is for rent for August or whatever on your check when you send it, so that the person who receives the check knows what's going on, what it's for. So we put in this encrypted memo field into every transaction in Zcash, and it gets encrypted with the same cryptography as the rest of the transaction. But the contents of the encrypted memo field are any arbitrary data that the sender chose to send. So the obvious use for that is to include like your customer number or a return address or a refund address, or to what address you want the goods shipped, or something like that. That's a communication between you as the sender and the recipient as the receiver. It's not visible to everyone else, but is append only and canonical and is visible to the recipient. But also, you can use this for anything. You can put arbitrary data into it if you want. If you had some application that you wanted to put data into a blockchain in encrypted form with selective disclosure, you can do it with a simple command line or RPC API interface here. And I have to tell you the most awesome story as soon as I figure out how to stop screen sharing again. Okay, still working on stopping screen sharing. Oh, I have stopped. Okay. This young woman told me that she received a Zcash shielded transaction, and in the encrypted memo field there was a pointer to a file, and she loaded the file, and I'm glossing over it. It was an IPFS file handle or something like that, some kind of hash which allows you to look something up on IPFS, but that's an irrelevant detail. So she received a transaction on the Zcash blockchain, and in the encrypted memo field, there was a file. And the file was a scan of some tickets to an event that she had been talking about attending with her lover. So it's an encrypted love note on the blockchain. And allegedly, it exists on the Zcash blockchain, but I can't tell, and no one else can except for the sender and receiver. All right, so those are the first 3 features. I can't see y'all's faces, so I can't see if you're like eyeball glossing or you think this is awesome like I do or what. But
I can promise that there's giggling and laughing going on.
Oh, okay, right. Yeah, I can't hear you either. So, all right, good. Giggling and laughing. Thumbs up. All right, then so that was the main reason to do this at all. And I was talking to Alessandra before we started live casting here about Tumblebit and about the cryptography that we use to do these zero knowledge proofs. And I was pointing out to her that even though that technology, the zero knowledge proof cryptography is actually, I suspect, among the most newest and advanced cryptography that is getting deployed to the internet and people are actually relying on. And that's terrible. You really don't like new cryptography. It's really, it'd really be better if you could rely on older cryptography for the same things. But we had to do it this way when we started because this was the only way to have sufficiently strong privacy. I told you earlier the leakage of information about your transactions is surprisingly easy to leverage that given repeated usage and patterns, that it's surprisingly hard to suppress the degree of information leakage low enough to protect you from the loss of privacy and the loss of fungibility. And so the zero knowledge approach is really great because it basically suppresses the rate of information leakage as far as what's to almost zero. This is a silly, like, oversimplified picture, but really, on the Zcash blockchain today, if you do a fully shielded transaction, which I could get to later if you choose the under the hood choice in the which way adventure, then we can talk about the fact that not all transactions are shielded transactions. But if you do a fully shielded transaction today on the Zcash blockchain, then what gets added to the blockchain and is visible to all viewers of the blockchain is basically the timestamp of when you did it, plus one other timestamp, which is kind of a technical thing, but it's typically the time. It's typically the identifier of the previous block or of the block that was the current tip when you made the transaction. But aside from those two timestamps, no information about your behavior gets leaked into the blockchain. And so this is so little information that it makes me comfortable that it might actually protect users' privacy in practice. Although I must add that even this is still, I'm not entirely comfortable because this is only talking about privacy information, privacy leakage that gets added to the blockchain. But if you use the Zcash software and you don't run it over Tor, then your IP address is linkable to some of your actions by someone who's just watching the P2P network. So that's a different topic. But the point is, we did this because no one was yet making a cryptocurrency with this degree of strength of protection. And I thought that this degree of protection would be necessary in order to achieve real long-term fungibility. Okay, then while we were at it, we went ahead and bumped the max block size from 1 megabyte to 2 megabytes, and we went ahead and changed the block time from 10 minutes target to 2.5 minutes target. And then while we were at it, we changed the memory, we changed the mining proof of work from SHA-256D to a memory-oriented proof of work. Okay. Oh yeah, simple model. Okay, so what are y'all more interested in next? How Zcash is implemented, how it works, what we intend to do in the next half of a year or so, or what we intend to do 5 years from now.
So the choices are how it works now or long-term vision?
Hold on, let me look at my slides again. The choices are how it works now, changes that we have already announced we are intending to deploy in 2017, or long-term vision.
All right. It sounds like people want to know how it's working right now before we get to the future.
Okay, great. According to my little timer, I've been talking for 18 minutes, and I can totally keep going. All right, how it works now. So you've seen the little oversimplified model, which is this. This is the oversimplified Bitcoin. This is the oversimplified Zcash, and this is the fact that you can decrypt selectively certain rows of oversimplified Zcash. Now, what else do I have? Okay, here's the next thing. Maybe this isn't the next thing. This is more. All right, let's try this one. Here is this paper that was written by some of the scientists who invented this technique. And this is a very complicated looking figure, but I'm going to try to point out one simple, well, I'm going to try to point out the important parts of it. Oh man, this is going to be hard. Can you see my mouse pointer? RT. I don't hear anything, so I don't know if you can see this.
Yeah, we can see it.
Okay, good. So I can point at things. All right, so we have this tool of a zero knowledge proof, and we're going to use that as a black box for this layer. So with the zero knowledge proof, you can hold on a second. Need some more notes. All right. Here's my attempt to explain zero knowledge proofs as a black box, sufficient that we can then use them to explain how Zcash can protect the user, how Zcash can prove the validity of a transaction without revealing information about the transaction. Okay. Can y'all see this? I just typed some words on my screen in my Emacs.
It's a little small. I mean, if you could zoom in a little bit, that might help.
How's that?
Perfect.
The cryptographer in the audience, Alessandra, can interrupt me if I say anything incorrect. The kind of zero knowledge proofs that we use in Zcash, these modern ones that I mentioned, were necessary for this approach, allow us to prove that a certain string is the output of a certain program. So let's say O is the string, F is the program, and I is the input. And then I'm going to make a zero knowledge proof that if you take input I, you feed it through program F, that O is the result, and P is a proof that O is the result. And calling it a zero knowledge proof means we're not going to reveal anything to you about the contents of I. Okay, now I really need to see how many people have glazed eyeballs and are checking their email. How are we doing so far? Does that make any sense? I'm not sure if this is a
Yeah, we're getting there.
description. Okay, so the point of this is these kind of zero knowledge proofs are very general. They work for any program, F. You can plug in any program. So if you had a program that said your input is 3 numbers and I'm going to multiply them together. So You could define F. Okay, I speak Python. Does anybody here speak Python? There. Here's a program which takes three numbers, multiplies them together, and returns the product. All right? You could plug this program into the system. You could plug in your three numbers. It would result in the product O. It would also result in a proof P that you knew these three numbers, that you put in three numbers, but it wouldn't tell you what the three were, right? So this is dumb if they're small numbers. But if they're cryptographically large numbers, then this is potentially useful. For example, I can have a program that says, take the SHA-256 of the input and tell me if it equals a certain hash value, right? Pausing again, but I can't hear anything and I can't see you, so I'll just assume that you're all nodding. Okay, fine. So yeah, unmute and tell me if you are not nodding and you're confused and you want me to back up. Oh yeah, I have an error. Unmute and tell me when I write bugs in my programs.
Oh,
okay, so
that won't result in a DAO or anything. It'll be fine.
Yeah, exactly. So you could have a program which takes an input and returns whether the SHA-256 of that input equals a certain number. Okay. Then I could run that program with a zero knowledge proof, and I could put in my input I, and it could return true or false and a proof. I guess it's interesting if it returns true, and a proof that this is the output of the program. Well, now this is interesting because if this returns true, then that proves I knew the input, right? It proves that it proves that I put in this value, which matched with this hash, but because it's a zero knowledge proof, it doesn't reveal anything about I, the recipient, but it provides a proof that I knew I, without revealing anything about I. Okay, that's my attempt to describe zero knowledge proofs as a black box. Now, here's my attempt to use such a black box to prove that you made a transaction in a distributed ledger without revealing anything about your private information. So on the left here is a Merkle tree of all of the, let's call them coins or notes. Let's call them coins. All of the coins in the system that have ever been made. You are the owner of one of those coins. And this is a publicly visible Merkle tree that every miner has of all the coins that have ever been created. Now, you're going to provide a zero knowledge proof that proves you're the owner of one of these coins without revealing which one. And you're going to provide a Merkle tree proof that the coin you're the owner of appears somewhere in this Merkle tree, but you're not going to reveal where in the Merkle tree it appears. Only that when it gets hashed with a few other things, that hash results in RT. But you're not saying what other things you have to hash in. The other things that you have to hash in are all part of your I, your input. So you're proving you know a way to hash from one of these leaves to RT, but you're not revealing which leaf or what other parts of the Merkle tree you have to include to reach RT. And then also, you're gonna prove that you know the secret key, which corresponds to that leaf. That proves that you're the unique owner, the only authorized spender of that coin. And you're going to prove some other details, which includes V, the value, how much Zcash that coin is worth. So with a zero knowledge proof and a whole bunch of cryptography, well, it's almost not cryptography at this point because we can bake it all into this function f that we write. So we write a function f which takes a secret key and a value and a Merkle tree and emits a proof that you knew some secret key which combined with all that other stuff resulted in the globally publicly known root of all the coins ever. Okay, I'm going to pause there. That is my next attempt for how it works under the hood. How are we doing?
All right. It sounds like we've actually got our first question here.
Hi, my question was the 7 other inputs that are combined with your input in the Merkle tree, are those from you or are those from other nodes? And if they are from other nodes, do the 7 inputs have to be from trusted users, or is it a completely trustless Merkle tree?
Okay, that's a great question. I'm so glad of that question because it shows that you actually understood the whole rest of what I just said. That's great. So the answer is this is a Merkle tree of all the coins that have ever been created, and untrusted users can create a coin, but they have to receive a transaction. Well, for their coin to have greater than 0 value, they have to have a proof that they receive value from someone else. But anyone can create a coin. You have to pay a transaction fee to get the miners to mine it, and then they will, when they mine it as part of their mining job, they add that coin to the Merkle tree of all coins. Does that answer the question?
Yeah, sounds good.
Cool. Any more questions?
I think everybody's oh, wait. The cryptographer. Here we go. Let's play Stump the Zooko.
Alessandra wouldn't do that. She told me before that she wasn't going to stump me.
No,
No,
I
it's
have
fine.
a
Seriously, what's
really
your question?
simple question. When I have to make a transaction, do I need to know the other commitments, the other coins?
That's a good question. The answer is when you, yeah, that's a good question. And it kind of points to part of the story that I didn't tell just now. I told how you prove privately, you prove that you know the secret that controls one of the coins without revealing which coin. But I didn't tell how much about how you add a new coin to the tree. And the answer is when you're spending a coin, you need to reveal 0 information about which coin you're spending or how much it's worth or anything. 0 information as much as possible. When you're creating a new coin, you can reveal what we call the CM. I'll just go back to screen sharing. Share. So when you create a new coin, this thing on the right is kind of the structure of a coin. And CM is the output of some secure hashes. COMM stands for commitment, but a commitment is just a fancy crypto word for a secure hash, basically, in my opinion. But anyway, so CM is the output of some stuff. And knowing CM does not reveal anything about the rest of the stuff. So when you create a new coin, you can publish CM to the world. You can say, hey world, hey all miners out there, here's my new coin commitment, CM, please add it to the tree. Therefore, the miners can then do the job of baking it into the Merkle tree. So you don't have to know all the other, create a new one. But somebody has to know the Merkle tree in order to add in order to generate the new Merkle tree. Does that answer your question, Alessandra?
Yes. Just last question. When I have to make the proof, I still need to know all the parents of the tree, the parents of my leaf, because when I pay, I'm proving that I know one leaf.
Yes. Yes. When you spend a coin, you have to know the uncles, I guess you might call them. All of the adjacent pieces of the Merkle tree going up to the root.
Okay. And this is, yeah, I mean, I guess this is information that I need to get from the blockchain.
Right. You get that information from the blockchain. Wait, let me think about that. You need to know that. Yeah, you need to know that. Yeah, you get it from the blockchain and then use that to generate your proof.
Okay.
That's why there's another bit of information linkage, by the way. This is sort of one of the details about which Zcash is not perfect, is which Merkle tree root your proof results in. Like every time a new block comes out, if there was at least one new shielded transaction that block, then that block contains a new Merkle tree root. Oh, you don't have to get that. Maybe. Yeah. Anyway, so so basically every block there's a new Merkle tree root of all the known coins ever. So when you make a proof, you have to choose. You have to make a proof that proves your coin belongs to one of those Merkle tree roots, and that's revealing information. Which one you choose reveals a little bit of information. Like I mentioned earlier, it's a timestamp. So what time you posted the proof to the blockchain and which Merkle tree root your proof anchors in are two timestamping bits of information.
And you're basically talking about the entire unspent transaction output set, right?
Right.
So you know, as you continue to accumulate coins over time, you could have, you know, these coins in all different places throughout that tree, right?
Yes.
Or at least
There's a thing
assuming that you're
where
generating new addresses, right? I'm not entirely sure, you know, how much you use like address reuse. I guess that might not matter as much if you're using shielded,
well,
right?
right. Let's distinguish between UTXOs and addresses and say an unspent coin. Actually, we call them notes. And the reason we call them notes is because they have values on them. So they're not of fixed denominations like 5 cents, 10 cents, 25 cents, like a coin is. But they have an arbitrary amount of value in each one. So because we have privacy at this layer, that means you can reuse your payment address. Like in Bitcoin, people are always haranguing you to rotate your payment address or use stealth addresses or something. But with Zcash, you can just reuse the same payment address continually, as long as you don't mind that everyone who pays you could notice that they're each paying the same payment address. Make sense?
So the payment addresses are, well, public or potentially leaked information?
Say that again?
Or are you saying that the payment address is publicly, it's information that's publicly accessible by other parties?
What I'm getting at is Zcash has got better usability than Bitcoin in this way, because you don't need to generate new addresses and retire old addresses in order to try to recover a modicum of privacy. So now you can use a Zcash address and reuse it as much as you want, and it's not going to reveal anything about linkage, about how much you're receiving or from whom you're receiving or to whom you're paying. The only thing it's going to reveal is that you're using that address. So if you want to have privacy in the sense of I want one address for business and a different address for personal, well, that wouldn't even be privacy. That would mostly just be to keep your accounting straight, right? But if you have two different addresses that you don't want anyone to realize that you control both of them, then you would use the two different addresses in those two different contexts, like two different social networks that you use, and you don't want people linking you on one social network to linking you on a different social network. So you might have a different Zcash address, one for each network.
Gotcha.
But other than that, you do not need, if you wanted, you could just have one address. You could post it on the side of a bus as an advertisement or whatever. That would be fine too. So my point is, you were asking about UTXOs and about addresses, and I just want to emphasize Zcash offers an option which could be more usable for a lot of use cases, by which I mean easier to use for a lot of use cases without losing privacy compared to Bitcoin. And then on the topic of UTXOs, likewise, since each note is fully private and since it can hold arbitrary value, it's fine to combine all of your inputs into one note. See what I'm saying?
Yep. In terms of, I guess, other privacy considerations, though, like, is everyone in using Zcash currently using it as a full node, or do you have like SPV nodes, SPV clients, or other lightweight nodes that could potentially have other privacy problems?
All right, to answer that, allow me first to go further into the under the hood. Oh, let me turn on screen sharing. So the question is everyone using shielded transactions, full nodes? Well, no, the question was, is everyone using full nodes or SPV nodes or light clients of some kind? To answer that fully, let me first go back to my slides. So the answer is we still retain transparent addresses and transparent transactions that we inherited from Bitcoin. So at one point, maybe a year and a half ago, I think, we had a momentous decision, said, shall we turn off Bitcoin script and the transparent addresses so that everyone has only shielded transactions all the time? Or shall we preserve the transparent addresses and all the Bitcoin script for sort of backwards compatibility and usefulness and ease of onboarding? And I decided to go the latter route. So you can start using Zcash today, and you can use it just like Bitcoin just like replace the name in your like script or your code from Bitcoin D to Zcash D, and it supports the same RPC API, and it has almost the same semantics for wallets and keys and transactions and all kinds of stuff. So it's very, very easy to add Zcash support if you already know how to use Bitcoin to your product. And that's really paid off because a lot of companies have added Zcash support right away, and people are able to use it already, even though a lot of those companies have not added support for the shielded addresses. But on the other hand, it's bad because now there are two kinds of addresses, which is more complicated. So go back to screen sharing. So here is the design, the core design of Zcash, starting with zero knowledge proofs as a black box, and then using that Merkle tree thing to prove the correctness of the use of an encrypted note. Now, in addition to that, we integrated it with Bitcoin script. So here, this T-adder here is a normal Bitcoin address. This SIG is a normal Bitcoin SIG that spins one or more UTXOs. And it produces a new UTXO over here, which is available to a different T-adder recipient. But you can also move value from the encrypted world into the transparent UTXO world, or vice versa, or both, in a single atomic transaction. Any questions about this?
Sounds like yes.
Hey, since you're using the Bitcoin protocol as well as the zero knowledge security layer, and since we're only able to use multi-sig through the Bitcoin layer, when will you ever be able to integrate the two? You know, That's one of the issues that,
a
let's say
great
we want multi-sig plus we want zero knowledge security.
That's a great question. That's a great question. And you know, I talk about Zcash a lot just to people like in coffee shops and conferences and give speeches and all kinds of stuff. And this is a widely raised issue, which tells me that multi-sig is super important. In fact, I've recently started thinking multi-sig might be most of what anyone needs a smart contract for, in fact. But that's a digression. But anyway, so multi-sig is awesome, and it's a smart contract, and we all need it. So with Zcash as it currently exists, you can, in fact, use it by, in fact, that's really a big part of why we kept it. It was really, multi-sig was the reason. I said ease of onboarding was important, and that was really important, but the other one was if we had gone the other route, then you wouldn't have any multi-sig at all on Zcash. And this way, you can do multi-sig and then mix and combine it with shielded transactions, and you get sort of partial privacy out of that. Like you could imagine you have all your Zcash in a shielded address, and you use that mixed transaction that I was just showing to move it into a Bitcoin UTXO. By which I mean I shouldn't call it a Bitcoin UTXO because this is all Zcash on the Zcash blockchain, but you move it into a normal old-fashioned UTXO, right? And then you can use it as part of a multi-sig transaction using only shielded input or sorry, only transparent inputs using the normal old Bitcoin script multi-sig. And then after you get the money out of the multi-sig, you could move it back into a different shielded address. Now, if you did all that kind of sandwich strategy, then you'd get some pretty good privacy because the shielded source and the shielded destination would not be linked to anything on the blockchain. But the amount involved and when the multi-sig was generated and resolved would all be visible on the blockchain. And it's kind of complicated. So, I mean, because there's multiple, multiple pieces to that strategy. So I really want to add encrypted multi-sig as a first-class feature in a near-term upgrade, hopefully in 2017. But that was on the near future path that we have not yet taken in our Choose Your Own Adventure story. Does that answer that question?
Yeah. So let's see. Did you forked off of Bitcoin Core? Was that like 0.11, 0.12?
It was 0.10. It was a long time ago.
So are you able to pull down the changes from that, or has it become too messy to keep up with upstream?
That's a good question. We didn't. In fact, I think, if I recall correctly, we actually forked off 0.9, and then we rebased onto 0.10 before launch, and then, or else, am I confused? Was it 0.10 or 0.11? I'll have to go look. I think I got that. I think I'm off by one. I think we forked off of 0.10 originally, and then we rebased to 0.11 before launch, 0.11.0. And then after launch, we were way too busy for months fixing all the bugs that we had introduced. And then just recently, in the last few weeks, we started going over all the numerous patches that Bitcoin Core has done since we branched off, and choosing the ones to cherry picking the ones to apply to Zcash. The engineers tell me, so I'm originally an engineer, but now I'm the CEO and I spend all my time sending email. The engineers who actually still look at source code every day tell me that it's a lost cause to try to rebase all the changes we've made onto all the changes that Bitcoin Core has made. But they have been successfully cherry picking specific improvements from Bitcoin Core and adding them into Zcash D. Does that answer that question?
Yeah, I mean, I can tell you myself that the changes between 0.13 and 0.14 were huge, just major refactoring. So I can imagine that it just becomes exponentially harder the longer and longer you wait, the further the two code bases diverge.
Yep, but it's already I'm assured that it's already a lost cause, that it would take infinite effort to rebase Zcash D onto 0.14. That's what they tell me. And so this is disturbing to me because there could be security holes in Bitcoin 0.11 that we inherited in Zcash and didn't notice and haven't fixed, that got fixed in upstream. But on the other hand, there could be newly added security holes in Bitcoin Core 0.14 that we didn't inherit since we haven't rebased. So it's kind of hard to tell what to do. But my current answer for what to do is ask the engineers to study patches applied to Bitcoin and look for ones that are important or valuable to Zcash, and also hire security auditors to look for security holes. Seems like the best we can do for now.
Any other questions?
He wants to go into his far future.
Far future plans for Zcash?
Far future? So you just skip over an year. In the near term, it'll get super awesome. And then in the far term, it'll get... You know, I don't really have slides or specific ideas for the far future. My dream is that Zcash and similar technologies like Bitcoin and Ethereum can become a fabric for global human society, both for economic, at least for economic transactions, and by economic I mean both payments and contracts. I think that the concept of decentralized, incentive-aligned cryptocurrency is going to turn out to be scalable in the sense that it's scientifically possible to let everyone in the world own some and spend some every day and engage in contracts with each other every day in a purely decentralized, resilient global fashion. Does that answer that question? That's pretty vague. But yeah, let's say about 20 years from now, everyone will use Zcash, Bitcoin, Ethereum, and their children for everything all the time.
Yeah, so you said I think you said the word scalability. So
also for love notes, don't forget the love notes in addition to the payments and the contracts.
Can you speak a little about Zcash's scalability, because aren't there basically larger data sizes required with the proofs?
Yeah.
So how well does it scale in comparison to other cryptocurrencies?
The zero knowledge proofs, the shielded transactions take, I think, about a kilobyte of data per transaction, which is maybe what, 3x or 4x a Bitcoin transaction, a transparent transaction?
Yeah.
The current Zcash blockchain has more capacity, though, because it's got twice as big of a maximum block size and 4 times as frequent of blocks as the current Bitcoin blockchain has. So until we had as many users using it as actively as Bitcoin, we wouldn't have we wouldn't be hitting any of the current capacity limits. I intend to. I'm pretty sure that by next year there will be improved scaling solutions that are well enough tested that we're willing to go with them. We have a kind of a philosophy of being the Goldilocks cryptocurrency, where Bitcoin is extremely conservative. It's Bitcoin has so far hewed to a policy, emergently so, has hewed to a policy of making changes changes to the consensus protocol, that is, much more cautiously and rarely and carefully, and requiring more of a agreement to do so than almost any network protocol that I've ever worked on. Contrast with Ethereum, which has demonstrated really remarkable agility and risk tolerance in terms of deploying new upgrades to the consensus protocol. And that's also rather more extreme than I would have gone in either of those two directions. And so this is really great that we have two pioneers out ahead of us that are blazing two different paths in terms of stability versus innovation. So we have this philosophy that this is great. Now we know that a mixture that's more innovative than Bitcoin, faster changing than Bitcoin, but slower changing than Ethereum, is probably going to be okay too, since both of the more extreme outliers are doing okay. So next year, 2018, so we have a full slate of improvements we want to make for 2017, and I don't expect we're going to run into too many users, before the end of the year. That'd be super great if we did run into that problem, but probably we'll still have plenty of spare capacity so we can have cheap transactions and everyone can have as many transactions as they want for the rest of 2017. And we have a bunch of crypto improvements to make in 2017. But next year, I think that the innovative consensus algorithms that have been devised by scientists over the last couple of years will be starting to get more well-baked so that we could pick one of those and upgrade Zcash to that.
Cool. And I guess in terms of governance, haven't you started a Zcash Foundation that is trying to tackle some of those issues?
Yeah. So in terms of governance, I kind of think the Zcash Foundation is the second branch of government or whatever for checks and balances, because the Zcash company is currently really leading, right? We can make a new version of the software and we can urge everyone to upgrade. So we intend to deploy a whole bunch of upgrades to the cryptography in 2017, and we expect everyone else to follow along, or if for some reason they don't like our cryptography upgrades, then we expect to have some kind of fork. But in the long run, having a for-profit company playing that role isn't really right, because that role needs to have basically a nonprofit that's expected and required by everyone to serve everyone equally. So there's this foundation. It has a whole bunch of money committed to it that gets paid out of the Zcash blockchain. So if Zcash continues to be valuable, then the foundation will get more and more money every month for the next 3.5 years. And the foundation is independent from me and independent from the company. The people who make up the foundation, at least the initial board of the foundation, are strong-willed individuals that I can't push them around, and they're not my employees, so I can't threaten to fire them and anything like that. So it serves as kind of a check and balance against the company. And their declared intent, if you go to z.cash.foundation, you can't see it on this little tiny font, but go to z.cash.foundation, and you'll see that their intent is to make an inclusive governance structure in which all stakeholders that are businesses, users, miners, public policy interested parties, and everything like that can communicate with each other and coordinate on the evolution and development of the protocol. So I'm pretty enthusiastic about this. I'm really glad about these people doing this service to the world.
Yeah, I mean, that is one of the other great experiments with all of these cryptocurrencies. It's not just the technical pinnings of the systems, but also the social aspect and the governance aspect. It's a lot of interesting developments going on in all these different currencies. But we did have one question about your mining algorithm. I think you said it was memory oriented. Was it Equihash? Is that correct?
Yeah, Equihash. So we searched around for a mining algorithm that would be ASIC resistant, or at least plausibly ASIC resistant, at least for now, so that there would be more decentralization and it would be easier for random enthusiasts to mine at first. We ended up, so we evaluated quite a few algorithms from some scientists, and we picked that one, and we hired an independent security auditor to study it and give us an estimation of whether there would, how it would likely play out. And then we had a competition for people to write open source implementations of the mining algorithm, and we got, I think, 4 really good open source implementations of it. And then we launched, and as soon as we launched, there was an explosion of mining activity, and the amount of hash power devoted to it was way higher than we predicted. I think, I don't remember for sure, but I think right after Zcash launched, the Ethereum hash power dropped by like 1/3 or something because of people switching over from mining Ethereum to mining Zcash that day. So that was fun. But Equihash has seemed to work out. As far as I know, there's been a lot of implementation improvement that has made it highly optimized and highly tuned for specific GPUs and stuff like that. But there's no indication that there's a custom hardware implementation yet. And there's no reason to suspect that there's any kind of algorithmic weakness in it that gives anyone a special advantage. So currently it seems to work as a decentralized proof of work.
Anyone else? I guess everybody's learned everything they want to know about Zcash.
Oh, good. I'm glad you. I was just gonna say no. You guys can't go yet. Everyone stay seated so we can talk about the near-term part.
Sure.
As soon as I find my slides. Where did I put my slides? My slides are in here somewhere. There they are. Okay. Oh, the near-term part isn't on my slide, but we announced our priorities, which I hope that we will finish this in 2017, but we haven't yet gotten more specific about the timeline of this. Soon, I hope we'll come out with a roadmap that actually tells you like what month you can expect all of these pieces. But we're going to keep fixing bugs and improving the performance of the daemon and whatever, making the API more usable in response to people who use our API, stuff like that. But also, we intend to do these 5 things. Payment disclosure is the method of, how if you're if you're like a Bitcoin exchange or Bitcoin business today, and one of your customers says, "Hey, you didn't send me my money," like they say, "I withdrew my Bitcoin and I never got my Bitcoin." What do? Well, you send them a link to a block explorer saying, "This is the transaction right here that we sent you your Bitcoin in. So go figure out why you don't see it." Now, with Zcash, you can't necessarily do that, right? Because assuming that they use shielded addresses and shielded transactions, then that's not visible to the public. But payment disclosure is basically providing that kind of workflow for shielded transactions, where somebody can say which payment that you made to me are we talking about, and you can send them a key which decrypts that one payment in the blockchain and no others. In theory, you could even use a block explorer, maybe the one that you're running locally for privacy, and paste that in, and then you would be able to see that transaction in the blockchain. So that's payment disclosure. It's the first item on our list. Screen sharing. Payment offloading is if you want to have a lot of people use Zcash on phone-based wallets like Jack's wallet, and you because because the cryptography to generate zero knowledge proofs is too expensive, you can't generate shielded transactions on phones yet. And payment offloading is a hack where you can ask a server to produce an encrypted shielded transaction for you, and then you sign it with your own signing key. So this unfortunately allows the server to find out who you're paying and how much, but it doesn't reveal to everyone on the whole blockchain who you're paying and how much. And it allowed you to initiate payments from your phone, and it doesn't allow the server to steal your money. So these are two sort of practical things that our current partners, which are like exchanges and wallet makers, could use right away. The next one is cross-chain atomic transactions. That is, you know about how you can use, looking for my stop screen sharing button, stop sharing. You know how you can use a hash time-locked contract on the Bitcoin blockchain?
Of course.
Good. So we're just working to implement and standardize those on Ethereum, Bitcoin, and Zcash, so that, and to get someone out there to facilitate using that for trustless atomic trade of Zcash for Bitcoin for Ethereum for Zcash. That's something else that is a relatively simple technology that we know we can implement and deploy in 2017. And it's probably also roughly the same thing as Ripple's interledger protocol. And it's also quite related to Lightning Network, although it's not the same as Lightning Network. Were you gonna say something, Jameson?
No, but
Okay.
is that kind of a shapeshift killer?
I almost imagine that Shapeshift would end up using it and being the like user interface to it, you know, because Shapeshift's got really good usability. And even if we implement cross-chain atomic transactions and we get them into Bitcoin and Ethereum and Zcash, and then anyone can swap a certain amount of Zcash for a certain amount of Bitcoin without relying on any third party, then you still need a marketplace where you discover people who want to trade with you and you agree on a price with them, right?
Yeah.
And there are some decentralized marketplaces out there, like the thing called BitSquare, which is now renaming itself to BISQ, B-I-S-Q. And there's this decentralized mobile app thing called waterhole.io, which will allow you to trade. It's kind of like local Bitcoins, but for trading currencies, among other things. Anyway, so your question was, would that be a shapeshift killer? And my answer is, I don't know, but if it were a shapeshift killer, then Shapeshift would adopt it and use it. And then it probably wouldn't kill them. Shapeshift has an admirable habit of minimizing unnecessary vulnerability, right? Like the whole point of Shapeshift in the first place was, instead of sending your money to the server where you will be vulnerable to your money getting stolen, instead we'll just take a small payment at the last moment just before we send you a payment. So that reduces vulnerability, but it doesn't entirely eliminate it. And then with XCAT, that can further reduce the degree of vulnerability by making it so that the server cannot steal your money in any case, even if it does get hacked right at the moment that you're making the transaction. Okay, I feel like we might be running out of time. My timer says we've been going for an hour and 7 minutes already. But the last two things that we're going to do, which are super awesome, the sapling crypto upgrade is going to it's going to be a hard fork upgrade, because other kinds of upgrading, like soft forks and all kinds of other hard soft sporks and whatever else people are talking about, all that's too complicated for me to understand. So I'm just going to tell everyone upgrade on a certain day. You're going to get this awesome new stuff. If you don't, well, then you're going to be on a different branch of the blockchain after that. But the awesome new stuff is going to be that the cryptography will be a lot more efficient. And I also hope to work in secure private multi-sig into here, although we didn't announce that because we didn't want to commit to it prematurely if it turned out to be too hard. But I really hope we get encrypted multi-sig into this upgrade, which will come within a few months. And the last thing is user-issued tokens, which is like colored coins, but instead of using a coin and coloring it and then tracing the behavior of that coin, instead it would just be its own first-class cryptography where you can create your own token type, and then you can use all of the Zcash machinery for encrypted transactions with your own tokens. Make sense?
Cool. I guess one more question here.
I'm totally happy to keep going and going. You can ask me questions. I could talk about this for hours.
On the user-issued tokens, how fungible is that going to be? As far as, like, let's say you have 10 tokens, are you going to be using that as your base, or is it just one token and you have a certain fungibility? Let's say X.
That's a good question. The answer is they're not like colored coins at all, so there's no tracing of anything. They're not even colored coins. It's just colored coins is the implementation that people recognize as a way to issue your own kind of class of tokens on a blockchain, right? But in this case, it's more like Ethereum ERC20 tokens where you can just define your own, except it's really not like that because it's actually private and fungible. So the answer is it's got it's got the same fungibility as Zcash has within each pool of a class of tokens. So if you issue 1 million Acme tokens, then people can make transactions in those and they have maximal fungibility because every Acme token is indistinguishable from every other. But there's no sense of fungibility between Acme tokens and Zcash tokens because those are completely different things, like dollars and yen, right? Does that answer that question, or did I misunderstand?
Yep. Let's see.
My question is about market adoption and what Zcash is doing to drive greater use of Zcash, and whether it's the foundation or someone else that's attempting to drive the use of Zcash beyond, cryptocurrency enthusiasts and more.
Yeah, that's a great question. That's one of my main interests nowadays, and I spend a lot of time talking to merchants who sell stuff on the internet, helping them set up to accept Zcash payments. And if anybody knows the alpaca socks guy, I totally want him to take Zcash for alpaca socks. I bought alpaca socks for Bitcoin in like 2010 or whatever, and I would totally buy alpaca socks for Zcash. So if anybody just wants to, if any alpaca farmers out there, get in touch. The foundation itself would very likely do this in the future once it kind of gets going more, but right now they're still like working on filing their 501c3 nonprofit paperwork and junk like that. I don't have any announcements I can tell you about yet, but I do have merchants that are currently in the process of signing up to start selling their wares over the internet for Zcash. We also work really hard to get wallets that are usable and accessible and familiar to users. Like, we're just announcing, it's already, this announcement is already public in Portuguese, but it's not yet public in English. But there's a wallet in Brazil that just added Zcash. So now there are 3,000 Brazilian people who already have that wallet who can now pay their taxes and their utility bills and their mobile phone charges in Zcash. Stuff like that. So I think about that a lot. I really think getting everyday use for normal commerce is absolutely the most important thing, and I'm working really hard on it.
Awesome. Just have to wait, I guess, for Zcash to take over the world.
If by wait you mean run around selling all day, yes.
All right. All right. Well, Zooko, it's been a pleasure, and we really appreciate you spending your time and educating us about the future here. So can we get a round of applause for Zooko?
Thanks, y'all. It was really nice seeing the backs of your heads. When we meet in real life, you'll have to tell me because I won't recognize your face because I never saw it. Okay. Thanks. Bye.
Thanks. Bye.